Welcome back to P-Spice. In this session, we'll continue with mastering instrument installation, wherein part 5. Part 5 will focus on design of, air supply line. So basically, we'll talk about the instrument air supply piping. And of course, we'll also touch upon a bit on the instrument air tubing. Okay, both the concept we will see here. So this is a typical look and feel wherein you have the main header, right? From the main header, then you have a branch off. Then from the branch off, you are connected to the, air supply to the plant floor. So this is the high level, but we will focus on after this connectivity, right? From here, how this is, distributed to our instrument requirement. All those detail we will see. Okay. So again, if you are a first time viewer, wanted to inform you, installation and control building and main cableway we covered in part 1, and field mounted instruments we covered in part 2. Installation of instrument impulse line and analyzer sample line, part 3, and heat tracing and installation in part 4. And in this section, part 5, we'll focus on instrument air supply piping and of course pneumatic signal tubing. The next session will talk about instrument wiring. Earthing we already covered. So yeah, there will be 6 parts totally. Okay. So if you're interested, you can watch and get benefited. Okay. Let's go with this concept now. See, in this design of instrument air supply line, so what is the method of air supply? Of course, as we all know, for field instrument, the individual pressure regulating method shall be adapted, meaning the field instruments will be there and the supply will be individually regulated, meaning with the help of a valve. After the tapping, you will have the valve. Then after that, it will be distributed to the particular instruments. The air supply piping shall be galvanized threaded common steel pipe. Okay. So up to the, from the main header, you will be using the galvanized threaded carbon steel pipe. Then near to the point, you will be having a SS tubing or copper tubing with the isolation valve based on the requirement. So this is the methodology involved. This we all know, but just want to, input as a refresher. Okay, now going back to the design of instrument as supply. See, there is some criteria which we need to adopt. Maybe you take this as a reference, friends. See, air supply pressure pipeline size. This is the air supply pressure. Okay. So 1.5 inch. If it is your 1/2 inch pipe size, if it is the pressure is 5 bar and higher, you can have a 1 to 10 taps, tap off, that is pilot. Okay. If it is less than 5 bar, and 1 to 5 pilots. Then if it is 3/4, slightly bigger, then you can go up to 11 to 30. And for this less than 5 bar, 6 to 15. So basically you can see like this is, if it is 10 means this is a 5. If it is 13 means this is 15. So depending on the pressure, so you can have a more number of pilots. So if it is 1 inch, 31 to 50. If it is for this less than 5 bar, it is 16 to 25. And if it is 1.5 inch, up to 120 pilots can be can be can be taken. Okay. So here one point you might ask, when volume boosters and cylinder actuators for control valves which consume large quantity of air are included. So then what we will do? Yes, the pipe size shall be determined depending on the actual volume. So that time the volume booster requirement, the cylinder requirement, all those we need to consider, okay, into the calculation. And of course, one spare 1/2 inch valve shall be provided in each branch from the main header. So that is the point. Okay. Okay. So I hope this is also useful for you. And now we'll go into the material specification. The standard size of the terminal valve, meaning the isolation valve, 1/2 inch. Okay. The termination of the instruments shall be a 1/4 inch OD copper tube with PVC cover on brass tube fitting, or 1/2 inch OD SS tubing. So this is again based on your project requirement. So material for instrument as supply piping shall be Pipe basically will go with this ASTM A106 generally, grade B, schedule 80 galvanized, and fitting ASTM A105 screwed galvanized, and valves ball type copper alloy body class 400 psi screw type. Okay, and of course sometimes weld also on the high pressure rating. Okay, Teflon tape or liquid thread sealant shall be used for sealing pipe threads. That one also we need to have it. Okay, so that's about the material specification. Now we'll go into the instrument pneumatic signal tubing. So this is just a small notes actually. As part of the design requirement, see, we need to have a single core tubing that shall be supported and protected by structural steel members such as, angle channel. Using that angular channel, we can route this, right? So air supply piping may be used to support one or two tubes. Even the air supply piping, right? The GA pipe, right? So that also can be, we can use it. That is a point. And tube shall be strapped firmly to the piping. So strap means we need to tie it. That's it. A simple thing actually. And of course, on this material specification, as signal tubing shall be quarter-inch copper tube with PVC copper cover and brass fitting or half-inch SS OD and tube fittings actually. And here also we have to use threaded tape or liquid thread sealant used for the sealing pipe threads. So this is just I want to give you about a simple notes, friends, on this instrument tubing and pneumatic signal tubing. Yeah, that's all I have for this. And next video, we'll talk about instrument wiring. Yeah, see you there. Thank you for watching. Bye-bye.